Hello everybody, and welcome to section 2. This section is on faults. This does cover a bit of review, so for those sections I might go a little bit quickly, but I've included links here to videos which review some of the content we've covered already. Don't hesitate to go into the PowerPoint, slides, PDF, and check those out. Okay. First, what are faults? So, rocks break all the time. Anywhere you go, out hiking, you see there's fractures all over the place in every single body of rock. But what makes it a fault is that this is a fracture along which the rock has moved. So it didn't just break, it broke and then it slid along that particular fracture. So we're talking about this, and there actually might be another one over here. And to answer your question, no, this is not me. Here. So faults are an example of brittle deformation. So cases where we have breaking, not bending, brittle deformation. This tends to be more common in cases where we have lower temperatures, so we're closer to the surface, because as we get deeper, things tend to get hotter. It's a case where we have a lot of pressure or force, enough to break rocks, and usually these are cases where we put a lot of force on the rock all within a single instant, from 0 to 100 very quickly, not a case where we put slowly increasing more and more pressure on the rock over time. This can happen for any rock, no matter the composition. All of them are subject to this kind of deformation. So this is a marble fault. We call it a marble fault because this is what we see most commonly, cases where we have break, like so, and where the hanging wall has moved down. In review, the hanging wall, you could hang a lantern off of it right there. You could also jump and hang here off the top of it. If we took this block away, you could jump and hang here off the top. Call this the foot wall because you could potentially stand on it, kind of at an angle, but still, if you were standing somewhere here in the middle, your feet would be on the foot wall. This is caused by tensional stress. So we're pulling apart. This is a case where hanging wall breaks off and moves down relative to the foot wall, as in this case here. So this would be our big normal fault, and we'd see, based on this, that it has moved down. And again, no, that is not me. So this is the directions of relative motion here. We moved down for this block, and relatively speaking, this one seems to have moved up. Sometimes we have a series of normal faults, a series of these sort of faults like we see in the diagram. These are all normal faults here. It leads to what's called the Horst and Graben landscape. These are German words, the result of a pair of normal faults. And what happens here is that we have this alternating series of uplifted blocks, or seemingly uplifted blocks, as well as down-thrown blocks, so lower blocks. I like to remember, Horst, it looks like it's been hoisted up. Graben, it looks like somebody grabbed it and pulled it down. These are going to be also, just like normal faults, a result of tensional stress, pulling these things out. These are going to be common in the Basin Range province. That should sound familiar because it's the geologic region that we live in here in Arizona, in the Phoenix area. So this is everything in here. Geologically speaking, this is all like one state in the geologic world. From here in Phoenix all the way up through Nevada. In Nevada especially, you get the very most clear-cut examples of sort of Horst and Graben structure, basin ranges. You could also have a reverse fault. So it's the opposite of a normal fault. That's why we call it reverse fault. It's a result of compressional stress. We take these two blocks and we squeeze them together until they break, and one of them moves up relative to the other. So here the hanging wall has moved up relative to the foot wall. So a good example of this is in Utah here. You're here to Chance, very, very lovely place to visit. You can see that we've had a break right here. This is our fault. And this bit has moved up the hanging wall relative to this part where our feet would be, the foot wall. It seems like it has moved down. So we can also have strike slip fault. So here, we don't really have a hanging wall and a foot wall exactly, even though that is what we see here on the diagram. Don't worry about hanging wall or foot wall for these. This is a case where we have two blocks which are sliding past each other along the fault. So the movement here is predominantly horizontal. It's caused by shear stress. We're sliding these two past each other. So this sort of motion, strike slip, fault, shear stress, is what we see here, San Andreas fault. Very, very famous. In this case, it looks like we have this sort of motion. So this part of the fault, everything on the North American plate, is moving in this direction, and it's sliding past Pacific plate here, which is moving northwest. And as a result, build up a tremendous amount of pressure right here along the fault. So what about Arizona? What's going on in our state? So on the West Coast, we had a switch from a conversion battery to a sort of transform battery about 25 to 15 million years ago. So geologically, this is somewhat recent. Again, life has been around for about 540 million years ago. So this is just the very most recent little episode. And as we switched from convergent to transform, we relieved some pressure that was being applied to the North American plate. And once that pressure has been released, we have the formation of San Andreas fault as well as crustal extension, pulling the entire plate apart since we've released all of this pressure on it. And the result of all this is normal faulting throughout the western U.S. through the Basin and Range province. And I have included a couple of videos here. These are all short. I would strongly recommend that you check these out, reviewing what is the Basin and Range. This video here, you should note that the next three numbers in the access code are 526. This one reviewing what we see as far as magnetism within the Basin and Range province. These are great review, short videos. Highly recommend go to the PDF and check this out. What we see finally, if we were to look at how things are in Arizona today, we took a cross section going from southwest to northeast right through the valley. This is what it would look like. So we have this series of normal faults, and what we get essentially is this series of mountain ranges and valleys. So we have an uplifted block, and then we would have the footwall, or excuse me, the hanging wall here, where we have this valley filled in with sediments. Next section is going to be on faults.